Okay, in today's video you will be able to write a geometric sequence in both recursive and explicit form. And remember, in the past videos we've talked about arithmetic sequences, so today we're going to look at geometric sequences. Okay, remember that an arithmetic sequence is just a sequence where each term is obtained by taking the previous term and adding a constant or constant d to it. So sequences like 1, add 3 is 4, add 3 is 7, add 3 is 10, and so on. That's an arithmetic sequence. A geometric sequence, on the other hand, is a sequence where each term is obtained by taking the previous term and multiplying by a constant r. Now, I don't know if you've noticed, but the d and the r don't really make sense when you're talking about adding and multiplying. Well, the d is a common difference, or a constant difference, and the r is a common ratio or a constant ratio. And that just means, like in a geometric sequence, if I multiply by 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. This has a constant r, or a constant ratio, and that just means you can find what number you're multiplying by working backwards and dividing. 16 divided by 8 is 2, and that works every single time. That's why it's called a common or constant ratio, because you find it by dividing. Same is true with an arithmetic sequence. You can figure out what the number that you multiply by is, or the number you add by going backwards and subtracting. 10 minus 7 is 3, and that works in every single step. That's the common difference. So just wanted to clear that up in case you had questions about why those were called constant or common differences or common ratios. So, and we just talked about that. So, a recursive form of a geometric sequence, a lot like an arithmetic sequence, is defined as you can find any term if you know the common ratio and you know the term before it. That's the recursive form. Only difference with geometric is that you're multiplying, you're not adding. Now let's look at this first example, which asks, are the following sequences geometric? And if so, what is the common ratio? Once again, you know that a sequence is geometric if the next term is obtained by multiplying the previous term by some common ratio. And sometimes you can just look and see it and it jumps right out at you, and sometimes finding the common ratio isn't so easy. So for this first term, or this first sequence, 3, 9, 27, 81, is it geometric? Well, in order for it to be geometric, there has to be a common ratio, so just pick two numbers, 81 and 27, and work backwards. 81 divided by 27 is 3. If this sequence is geometric, then the common ratio would have to be 3. Is 3 times 3 9? Yes. Is 9 times 3 27? Yes. Is 27 times 3 81? Yes. There is a common ratio. This is a geometric sequence, and the common ratio is 3. So the answer is yes, and the ratio is 3. In the next example, it's got fractions. Oh no! Fractions? I can't do fractions. Well, if you notice the top number in all the fractions, they're all 5s. So if this was a geometric sequence, then the common ratio would have to involve a fraction that has 1 on the top, because 1 times 5 is 5, 1 times 5 is 5, 1 times, and so on. If you look at the bottom numbers, 2, 4, 8, 16. 2, 4, 8. Let's see. How do I get from 2 to 4 and 4 to 8 and 8 to 16? Well, it could be 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. That makes the common ratio 1/2, and the answer to this is yes. Now, algebraically, what you could have done is worked backwards and taken 5/16 and divided by 5/8. That looks a lot more complicated than figuring out using common sense. Now, if you couldn't figure it out the way I did, this would be the method you'd have to use by working backwards. Okay, so for now we're going to skip the graphing part of this, so we're going to ignore that. But the directions for this example say find the common ratio of the geometric sequence with the first term, u1, being 2, the second term, u2, being 8. First term is 2, second term is 8. We just did this. To find the common ratio, you're going to take a number and work backwards and divide. 8 divided by 2 is 4. The common ratio is 4. Then it says, list the first 5 terms of the sequence. Well, 2 of them are already given, 2 and 8. To find the next 3, you just use the common ratio and repeatedly multiply. 8 times 4 is 32. 32 times 4 is 128. Now I'm going to challenge my mathematical skills. 128 times 4 is 2, 1, 512. Those are the first 5 terms. And then the last part says, write a recursive function. Well, how do I write a recursive function for a geometric sequence? The form for writing a recursive form for a geometric sequence is to take the common ratio and multiply by the previous term. So it's simple as writing 4 times u to the n minus 1. That's it. Okay, now the same thing applies with geometric sequences that applied with arithmetic sequences. A recursive form is great, except you have to know the previous term. The explicit form of a geometric sequence will help you find any term at any point without knowing the previous term. And just so you can see it better, it's written like this. Take the first term and you multiply it by the common ratio raised to the power of n minus 1. So let's take a look at an example. Write an explicit form of a geometric sequence where the first 2 terms are 2 and negative 2 fifths. Okay, first term is 2, second term is negative 2 fifths. So first thing I have to do is figure out what is the common ratio. The common ratio is found by taking a term, working backwards, and dividing. Negative 2 fifths divided by 2. Now remember, when you divide fractions, you can take the bottom, invert it, and multiply it. So I'm going to rewrite it like this. Negative 2 fifths times 1/2. Multiplying gives me negative 1/5. Common ratio is negative 1/5. So to write an explicit form, I first have to know the first term. Well, that's easy. It's 2. Then I have to know the common ratio. Well, we just figured that out. It's negative 1/5. And that's raised to the n minus 1. And that's the explicit form for this geometric sequence. Now the last part of that says find the first 5 terms. We already have 2 of them, 2 and negative 2 over 5. To find the next one, I'm going to multiply by negative 1/5, and I get positive 2 over 5 to the second power, 5 times 5, and then negative 2 over 5 to the third power, and 2 over 5 to the fourth power. Now, I wrote these in powers, but I could have written over 25, over 125, over 625. Okay, last example. This one can be a little bit tricky, but stay with me. It says the 4th and the 9th terms of a geometric sequence are 20 and negative 640. Find the explicit form of the sequence. Okay, I'm just going to keep reminding you the explicit form is un equal to u1 times r to the n minus 1. So in order to find the explicit form for this sequence, first I have to know the first term, then I have to know the common ratio. So there are several ways to do this. Here is what I think is the easiest way. The 20 is the fourth term, negative 640 is the ninth term. So 20 is the fourth term. That makes this the fifth, sixth, seventh, eighth, and then the ninth term is 640. Alright, first thing we're going to try to do is figure out what the common ratio is. The common ratio is the number I multiply each term by to get the next term. So if I start with 20, to get the next term I have to multiply that by r. And then to get to the next term I have to multiply that by r. And to get to the next one, I multiply by r, next one, multiply by r. And then finally to get to 640 I multiply by r one more time. And what you can see is 1, 2, 3, 4, 5 r's are being multiplied together, or r to the fifth. So this represents an equation that says 20 multiplied by r to the fifth, that will give me negative 640. And now I can solve for r. I do that by first dividing by 20 on both sides, and I get r to the fifth equals negative 640 divided by 20 is negative 32. And now I can either take the fifth root of both sides to solve for r, or I can recognize that there's a number raised to the fifth power that equals negative 32. That number is negative 2. So I know the r for the explicit form. Now I just have to find the first term. I could work backwards and get to the first term by dividing, and that would be an okay way to do it, but I want to show you a way that involves algebra so that you can do this for any number, even when it's a little more complicated. So here's what you do. You take the form un equals u1 raised to the n minus 1, and you pick one of the terms that are given to you in the problem. Let's say the fourth term, which is 20. So since the fourth term equals 20, then I can say u4 is equal to u1 times r to the 4 minus 1. Now, I know what u4 is. I know what the fourth term is. It's 20. So I'm going to put 20 here. And u1. I also know that the common ratio, which we just found, is negative 2. And 4 minus 1 is 3. So negative 2 raised to the third power is negative 8. And now I can solve for u1 by dividing both sides by negative 8. And that tells me that the first term, u1, is going to be 20 divided by negative 8, which reduces to negative 5/2. I know the common ratio is negative 2. I know that the first term is negative 5/2, so I can write the equation like this. u1 times r to the n minus 1. I know what you're thinking. Please, can I do another one? I'm sorry, we're finished.